Okay, alrighty. So we're the Python enjoyers. This is our project. So Sean, take it away.
Okay, so basically our goal was to predict whether a water bowl is able to be consumed or non-consumed by using classifying machine learning. And so we have a data set at the bottom with all of our data. And then on the top, we have all of the columns and short definitions to give descriptions of each of them. Like some of them, like hardness, sulfate, they have concentration of how much that is in the water, and then pH is a measure of acidity. And then our potability 1 is equal to it is potable, or 0, it is non-potable.
Okay, so for our visualization, first up we have a seaborne scatter matrix displaying one-to-one relationships between each column or data set, with blue representing non-potable data points and red representing potable ones. We see from this plot that there are no obvious graphical correlations between potability and any one or two other variables, meaning that we couldn't rely on models that use visual patterns to classify our data points, such as a logistic expression mark, for example. We then created a histogram and a violin plot, both showing the spread of data of certain variables, in this case conductivity and solids, and how they relate to potability. Once again, we see that there aren't really any obvious correlations. Potable and non-potable data points are spread evenly no matter where you look, which showed us that we would have to opt in favor of models to use slightly more complex methods of classification.
And now we have a heat map. This heat map shows how related potability is with other aspects of water. The darker the box, the more negative the correlation. We also have a scatter plot, and this scatter plot displays the correlation between the solids and hardness in the water sources from this data set, which appears to be none.
Our first model is the k-nearest model. We chose this model as a default to start our modeling process. The model has an accuracy of about 60% and a mean squared error of 0.407. The precision was around 0.17 and an F measure of around 0.24. Due to the fact that there was no clear distribution between potable and non-potable data points, the low accuracy of this model makes sense.
The reason we chose the decision tree classifier is because of its standard for classical machine learning. It's also a great model to use since we are doing a classification product. It uses conditions and nodes, and the query data point will iterate through, creating a certain output. This module was a little bit better than the KNN, around 66%. This model is the random forest classifier. The main reason we chose this model is because it's basically an extended version of the decision tree classifier. It creates multiple decision trees. In the end, they pick the output that most of the decision trees agree on, kind of like a vote. In conclusion, this was our best model we had so far, with an accuracy around 70%.
Okay, so this is our team. And in conclusion, we had 3 machine learning models: the k-nearest neighbors, random forest classifier, and decision tree classifier. The most accurate was the random forest classifier, which had an accuracy of around 70%. We actually found that changing the null values, not changing the null values made it more accurate than imputing. If we had more time, maybe we could try different imputing techniques to improve our accuracy or gather more data to have better trained models. If we were to change this problem to a regression problem, instead of classifying whether the water is potable enough to drink, we could scale water potability to usage. So you could use water for different purposes depending on the water's quality. So why did we do this? Well, we created this project because we want people to be able to know if they have a clean water source or not. Our hope is that this product will help millions of people around the world who live in the poorer areas determine if their water source is truly sanitary or not, so people don't get sick from drinking bad water. It does all of this by predicting the water's potability from thousands of data points. Thank you for listening.